Hi friends, welcome back. We're talking about similar polygons today. We're talking about finding areas. So in a previous lesson, when we are told that these two figures are similar, these are both squares. And I'll write that over here. So we know that they are similar because they are squares here, and I'm telling you that they're similar. You need to be told that. If I asked you to find the scale factor here, let's do this. We're gonna say the scale factor, and we'll call this one A and this one B, the bigger one B. So our scale factor for A to B is going to equal A over B. We have 1 yard over 3 yards, and then we cancel out our units and we're left with 1 over 3. So our scale factor for our sides or our perimeter is 1 to 3. But now we have to talk about the scale factor for our area. Well, first, before we do that, let's figure out what the area is for these. The area for this guy is just base. Remember, for figuring out the area of a rectangle or a square is just base times height, right? Or length times width. So this is going to be 1 times 1, which gives us 1 yard squared. The area for this guy is going to be 3 times 3, which is 9 yards squared. 9 yards squared. Good. So the scale factor for the area then is going to be scale factor for area for A to B is going to be A to B equals 1 over 9. Now, if you take a look at the scale factor for the sides, 1 to 3, you see that all we did was we take 1 to 3 and we square both the top and the bottom, and that gives us our scale factor for the area. This applies to area and surface area. So let's talk about that with surface area and with 3D figures. This can be a little confusing at first, so I think as we go through and work through some of these, it'll make a little bit more sense. All right, let's take a look at this. We're first going to find our scale factor. I'm going to call this guy A and this one B. So our scale factor for A to B for the sides or for finding, like, say, the perimeter of the base would be A to B. So A is, now I could choose 93 to 155, or I could do 60 to 100. I'm lazy. I'm going to do 60 to 100 because that's easier. Is 60 to 100. Lob off those zeros. I'm left with 6 over 10. Divide both those by 2, and you get 3 over 5. So my scale factor here is 3 over 5 for the sides and the perimeter of any part of it. Perimeter. Okay, now what about that area? The area is going to be the scale factor, which is 3 over 5, and we square both the top and the bottom. We find 9 over 25. 9 over 25. In fact, for this first one, you know what? It's a good idea. Let's work through that so you can see. So we're going to ignore number 2 here. And we're going to say, okay, the surface area for a cylinder, and you may write it a couple of different ways, but I do 2 and then r squared plus r times h pi. There is my surface area for a cylinder. So if I look at for A, right? I get a surface area that equals 2 times the radius. So the diameter is 60 feet. It's a little hard to see. Sorry about that. So we're going to say the 30 squared plus 30 times the height, which is 93 times pi. So if we have that, we end up with 30 squared plus 30 times 93, and notice I'm putting it into my calculator with parentheses, so I have some nice order of operations in there. So we end up, and then multiply whatever that is by 2, so we end up with 7,380 pi for the first one. Now for B, we have the surface area equals 2 times the radius, which again, the radius is half of this, so it's going to be 50 squared plus 50 times 155. And then multiply all that by pi, and we're going to do the same thing. We're going to say 50 squared plus 50 times 155, and then multiply whatever that is by 2. So that's going to be 2,500 pi. Okay, so let's see now. If we compare the ratios of A to B as far as area goes, we would have, let's see, 7,380 pi over 20,500 pi. Lob off the pi and lob off that 0. We end up with 738 over 2050. And if we reduce this down, let's see, we can do, oh, we divide by 82. I know it would take a while to get there, but if you divide by 82, we end up with 9 over 25. So then we look at that and you see that's exactly how we got the area, the ratio of those areas, without having to find the surface area of both of them and then compare it and then reduce it down. So this is the long way of doing it, but if you find the area, or I'm sorry, if you find the ratio of the sides or of like the perimeter of any part of the figure, then you can figure out the area. So let's try another one of those. Let's look at this guy right here. So looking at this pentagonal prism, we have 70 and 100 kilometers. I could also do 63 and 90, but again, I'm lazy. I want to make it easier, right? And I'm going to call this A and this B. So A to B is going to be 70 over 100, lob off my zeros, and I get 7 to 10. So this is the ratio of sides. Now, the ratio of area, remember, we just take the ratio of the sides, which is 7 over 10, and we square it. So we get 49 over 100. So the ratio of the area would be 49 over 100. Now, let's talk about when you're given the area. And so like this guy right here, I've got number 7. I have 2 cylinders. Cylinder A is 392 and cylinder B, pi feet squared, and cylinder B is 128 pi feet squared. Okay, so now at this point, I want you to figure out your scale factor or your similarity ratio. Sometimes it's called one or the other. So here's what we have to do. And specifically, I'll say A to B. Also, each pair of figures is similar. You got to be told that, right? So A to B, we would do 392 pi over 128 pi. Lob off those pies. And then at the very least, let's see if we can reduce this. Well, I mean, I know we can reduce this, but we can divide by 2. So let's see, we do, bear with me here. I just messed that up, 3. Okay, if I divide by 2, I get 196. And if I divide this by 2, I end up with 64. Now, this is where it's good to know your perfect squares, because I look at that and I see, aha, I have 2 perfect squares that are there. I could reduce them again. Let's see. If we did, this would be, wait, 196 divided by 2. Oh, yeah. So this would be 98 over 32. And I can reduce that again, which is going to be 49 over 16. And so at that point, I can't reduce any further. But now I know that these are perfect squares. And so that is 7 over 4. So the ratio, or the similarity ratio, or the scale factor is 7 to 4. And we know that because we took these guys and we found those perfect squares. Because remember, when the area part of it is squared. I know I get a lot of kids that are mixed up on this. So I want to kind of help you out do this again. Also, looking back here, I saw that these were perfect squares. I happen to know that that's 14 squared over 8 squared. But see, you can reduce that. If I cut that in half, I get 7. Cut that in half, I get 4. Or you can reduce this number. So we ended up with 7 squared, which is 49, over 4 squared, which is 16. So 7 over 4 is my scale factor. Okay, so now looking at this one, let's see if we can, given the surface area, let's see if we can figure out the scale factor. We'll call this again A and B. So A to B. A to B, we get 80 over 5. Well, if I take 80 and divide that by 5, I don't know why I can never remember that 16. Divide that by 5 and we get, divide by 5, we get 16 over 1. So that is the ratio of the areas. However, our scale factor is going to be 4 squared, 1 squared. So our scale factor is 4 to 1. 4 to 1. Okay, so hopefully that helps you out. If you have any questions, leave them below. Otherwise, we will see you next time.